Hello everyone, welcome to the channel. This is the final lecture of continuous beams. In this lecture I am going to give an example of support sinking. Till now we discussed continuous beams in the four parts. The first part is how to analyze the continuous beam, and continuing with an example of some simply supported continuous beam analyzing. Later on, in the second part I had discussed regarding a continuous beam with a fixed support, how to analyze a continuous beam with a fixed support. And in the third part I gave another example with a fixed support and varying flexible rigidity, and this is the final part. In this I am going to give an example regarding the how to analyze a continuous beam of support sinking. So this is the example. The question is, analyze the continuous beam by three moment theorems if the support sinks by if the support C sinks by 8 mm. Take EI value as 20,000 kilonewton meter cube. So this is our beam given. So the first step is to draw the free bending moment diagrams. Prior to that, since this is a fixed support, we have to assume another span A0A, which we have to assume, for which A is 0 and length is 0, everything is 0. Just for calculating this moment here, we have to assume this span. Now coming to the free bending moment diagrams, for the span A0A, it will be a straight line. The value here, the bending moment here is 0, since there is no load, nothing. This is an assumed value, assumed span, so the value will also be 0 here. Now coming to the second span AB. Now here there is no forces here, so RA and RB, RA plus RB sigma Fy is equal to 0, which gives me MB. And now I am calculating MB as 0. So the forces here is RA into 4 left side, so it will be positive, and this 20 is also positive since it is left side anti-clockwise movement. Sorry, left side clockwise movement, it will be positive. So RA into 4 plus 20 is equal to 0, which gives me RA as minus 5, and by substituting this RA value as minus 5 here, we will get RB value as plus 5. So now the bending moment diagram will be that is, we have to calculate moment here. So from the left span, this will be my bending moment diagram. That is, here it is minus 10, since from due to RA it will be minus 5 into 2, which is left side and anti-clockwise. So it will be negative. So minus 10 will be the moment here due to RA. And coming to the right side span, this will be my moment diagram, which is RB into 2, that is 5 into 2, which is right side anti-clockwise moment, so it will be positive. So finally I got here moment as 20. So this is the free bending moment diagram for this span. Now coming to span BC, the value at this point, moment at this point will be WL by 4, that is 30 into L is 4 here, and divided by 4 we will get a value as 30. So since it is a point load, it will be in a triangular pattern. So this is the bending moment diagram for the span BC, triangular pattern, and the moment here is 30 kilonewton meters. Now coming to this span CD, since it is a free support here, there is no support here, and the load here is 10, the moment at this point will be minus 10 into 1, that is minus 10. So this is my free bending moment diagram. Now the step 2 is to calculate the centroid area and lengths of this bending moment between 2 points. So the first span here is A0A, for which everything will be 0, since it is an assumed thing, assumed span. Now coming to second span AB, till now in previous problems we had calculated the area for the total span at a time, but since there is some difference here, since it is a negative one and this is a positive one, just calculate them separately. I mean this span AB is of area A1, but we will get 2 A1s, 2 XLs, 2 XRs here for this span. So while we apply in this formula of 3 moment theorem, then we will adjust these values accordingly. So now for this span AB, for this A to some here, the area will be half base into height, that is half minus 10 into 2, which gives me area as minus 10, and XL from here will be 2/3 of this length, that is 2/3 of 2, which is 1.33, and XR from, that is from here, it will be 1/3 of 2, that is 0.67. Now coming to this span, from this here to B, again the same operation takes place. A1 is equal to half base into height, that is half plus 10 into 2, that is 10, and XL will be that is from here it will be 1/3 of 2, that is 0.67, and XR will be 2/3 of 2, that is 1.33. Now coming to the span BC, area is half base into height. So here base is 4 and height is 30. So my area will become half 4 into 30, that is 60. And coming to XL, that is from here it will be at the center. Since it is a pointed acting at center, XL value will be at center. And same for XR also, that is 4/2, that is 2. Now actually we don't need this value, since we will use two equations only, that is for A0 AB and ABC. We don't need these values, but for knowing the calculation I am giving these values. A3 is equal to half base into height, that is half 1 into minus 10 here, that is minus 5 value, correct it. It is half base is 1 and height is minus 10. We will get minus 5 as the value. And XL is L/3. From here it will be 1/3 of L, that is 1/3 of 1, that is 0.33, and from here it will be 2/3 of L, that is 2/3 of 1, that is 0.67. This is step 2. And coming to the step 3, we need to apply the 3-moment equation. So here we will apply the 3-moment equation for two spans, that is for A0, AB and ABC. So these are our calculated values till now, that is A0 values, A1, A2 values, and L0, L1, L2 values, and XL values, XL and XR values. Now this is the question given. There is no deflection, that is no, here the question is, there is a sinking of support of 8 mm at support C. Note it here, if the support C sinks by 8 mm. So here the values are delta A is 0, there is no sinking of support at support A and B and D. There is only sinking of support at C, that is 8 mm. Since it is sinking downwards, it will be negative, and 8 mm is converted into meters. 8 into 10 to the power minus 6, that is 0.008 meters. So these are our given values and these are our calculated values. So now applying 3-moment equation for span A0 AB. So this is our 3-moment equation. We already know about it. Now here actual 3-moment equation is MA into L1 plus 2MB into L1 plus L2 plus MC into L2 is equal to minus of 6A1 x1 bar by L1 minus 6A2 x2 bar by L2 plus 6EI delta A by L1 plus delta C by L2. So coming to this particular problem, till now we didn't use these values. Till now we got this value as 0 since there is no sinking of supports. But now in the case of second equation, that is in the case of delta C, first equation is for A0, A and B. So there will be no delta C value. We will get only the delta A0 and delta B values. Both are 0. So no issue with this first span. The second span is A, B and C. So here we will get delta C value. We have to substitute that value here. That is the only difference for this problem and before problems. So now for span A0, AB, the 3-moment equation will become like this: M A0 L0 plus 2 MA L0 plus L1 plus MC MB into L1, which is equal to minus 6 A0 x0 bar by L0 minus 6 A1 x1 bar by L1 plus 6 EI delta A0 by L0 plus delta B by L0. Coming to our previous lecture part, we discussed regarding a change in flexural rigidity. So in that case we took here L0 by EI, L1 by EI, so on. So now since this is of same flexural rigidity, we can omit it. We can leave that part. So now coming to this one, I am substituting these values here. So my A0 value, L0 value is 0. Okay. Now MA, 2 MA into L0 plus L1. Here L1 is total this span. So it is 2 plus 2, 4. And MB plus MB into 4 gives me this here. Coming to RHS value, minus 6 A0 x0 bar by L0. Everything 0 since it is an assumed span. Now coming to this minus 6 A1 x1 bar by L1. Now this we are applying this 3-moment equation for span A0, A and B. So here x for span this span A0 A, the x bar value will be, that is x0 bar here. x naught bar will be xl, which is 0. Now here for span AB, the x1 bar will be xr, opposite to the center point. So this will be xr. So we should calculate x bar value from this point B. So for that purpose, here my minus 6 into my A1 value becomes A1 into x1 bar. I am calculating both at a time. A1 into x1 bar. So from right hand side, that is from this point to this B. So A1, that is 10 into my x r will be 1.33. So 10 into 1.33 is our xr for this point. Now coming to this point, so I calculated from here to here A1 into x1 bar. Now I should also calculate from here to here also, that is A1 into x1 bar for this point will be A1 here is minus 10 and x1 bar that is xr from here to this point is, from here it is xr is 0.67, from here it is 0.67 plus this 2, from here it is 2. So 2 plus 0.67 gives me 2.67 divided by L1, that is 4. And here the delta I0 is 0 and delta B is 0, so I took it as 0. Again I am giving you a clear explanation for this part. So listen, minus 6 A1 x1 bar by L1. So this is minus 6 and L1 here is 4. Now coming to this A1 x1 bar, A1 x1 bar, since this is we are taking the span A0 A B, for this span A0 A, it will be XL, that is from, we have to calculate x bar from this point. Now coming to this point, it is XR. I had already given you explanation regarding how to take XL and XR. We have to take opposite one to the center point. Here the center one is A, center support is A. So opposite to that one we have to take, that is XR. For this span, it is we have to take from right side, so it will be XR. So here coming to we divided this span into two parts, in A, from A to here and from here to B. So since it is from XR, first we have to consider this right side one. So for this one, area is 10. So A1 into x1 bar here is XR, that is 1.33. So we completed A1 x1 bar for this span. Now we have to also calculate A1 x1 bar for this span. That will be, here A1 is minus 10 and XR we have to calculate from this point, right? So XR from this point will be, from this point it is 0.67. From this point it will be 2 plus 0.67, that is 2.67. Clear? So this is how we will consider when there is a couple acting at the mid of this span. So this is the 3-moment equation for A0 AB. Now by solving this, we will get an equation as 8 MA plus 4 MB is equal to 20.1. Mark it as equation 1. Now applying 3-moment equation to the A, B, C. So the 3-moment equation is for ABC, it will be MA into L1 plus 2MB into L1 plus L2 plus MC into L2 is equal to minus 6A1 x1 bar by L1 minus 6A2 x2 bar by L2 plus 6EI delta A by L1 plus delta C by L2. So here delta A value is 0, but delta C value is minus 0.008 meters. So we have to substitute that value here. Now here MA into L1 is here, L1 is 4 and 2MB into 4 plus L1 plus L2, that is 4 plus 4, that is 8 plus MC into L2 is 4. Now here again for this span AB, this is for span AB and this is for span BC. So for span AB, now since the mid support here is B, for this span ABC mid support is B, so we have to take for span AB we have to take XL, and for span BC we have to take XR, that is from point C. So here we have to take XL. So here minus 6 by L1 is minus 6 divided by L1 is 4. Now A1 x1 bar here will be XL, that is minus 10 into 1.33 for this span from A to here, and from here to here L is 0.67, but we have to take it from here. So 2 plus 0.67, 2.67 into the area for this span is 10. So 10 into 2.67. So this is how we have to calculate this. Again I am repeating this value. 6 into minus 6 into L1 is 4 here. Minus 6 divided by L1, so minus 6 divided by 4, and this A1 x1 bar is, we have to consider it from left span. So XL for this one is minus 10 into XL is 1.33, and coming to this span from here to B, XL is 0.67 and A1 is 10, but from here XL is 0.67, but we have to consider it from here, so 2 plus 0.67, 2.67 into 10. Now coming to this one, minus 6 A2 X2 bar by L2, here it is X2 bar, here is XR, so for this span XR is 2, minus 6 into A2 is 60 into XR is 2 divided by L2 is 4, plus 6 EI into delta A value is 0, so this value becomes 0, 0 divided by 4, plus delta C is minus 0.008 divided by 4. Now by simplifying this equation by substituting MC value as minus 10, since the moment at this point will be due to only this force 10 on the right side, so since it is a right side clockwise moment, it will be negative, minus 10 into 1, that will be minus 10. So by substituting this minus 10 here, we will get an equation as 4MA plus 16MB plus 4MC is equal to minus 440.1. And here by substituting MC value as minus 10, we will get an equation as 4MA plus 16MB is equal to minus 400.1. Mark it as 2. Now by solving these two equations, we will get 8M. I'm simplifying these equations. Sorry, let me paste these equations here. I forgot to paste these equations. So this is equation 2. So this is my equation 2, and coming to equation 1, this is equation 1. So I pasted these values here. Now, so by solving these two equations, that is here it is 8MA plus 4MB is equal to 20.1, and here it is 4MA plus 16MB is equal to minus 400.1. So I multiplied it with 2 and my equation becomes like this. So by subtracting this equation from this equation, we will get minus 28 MB is equal to 820.3, and finally by solving we will get MB value as minus 29.29 kilonewton meters, and by substituting this value in either of these equations 1 or 2, we will get MA value as 17.16 Newton meters, kilonewton meters. Mark it as kilonewton meters. Now, so finally the moments of this beam is MA is equal to 17.16 kilonewton meters, MB is equal to minus 29.29 kilonewton meters, and MC value is minus 10. Now coming to the next step, finding out the support reactions. So to find out the support reactions, I divided the beam into 3 spans AB, BC and CD. So coming to the span AB and applying sigma Fy is equal to 0, RA plus RB is equal to 0 since there is no force here. And now coming to moment, I am considering moment at this point B is 0. So the forces which contribute to this moment are RA into 4 will be the moment here, and since it is left side clockwise moment, it will be positive, and the moments and couples which contribute to this moment are 17.16, 20 and 29.29. all are left side clockwise moments, so all are in positive. So RA into 4 plus 17.16 plus 20 plus 29.29, which is equal to 0, and by solving this we will get RA value as minus 16.61 kilonewtons, and by substituting this RA value in this equation we will get RB value as 16.61 kilonewtons. And now coming to the second span BC, RB plus RC is equal to 30 kilonewtons, which is sigma Fy is equal to 0. Now considering moment at this point MB is equal to 0, the forces contributing to this MB are only RC and 30. So this RC into 4 will be positive since it is acting right side anti-clockwise moment, and this 30 will be minus 30 into 2 will be negative since it is acting right side clockwise, so minus 30 into 2, and moments that are contribute to this moment here will be this 29.29 which will be positive, and this 10 which is negative since it is right side clockwise. So finally RC into 4 minus 10 plus 29.29 and minus 30 into 2 which is equal to 0, and by solving this we will get RC value as 10.17 kilonewtons, and by substituting this RC value in the this equation, we will get RB value as 30 minus 10.17 kilonewtons, which gives me RB value as 19.83 kilonewtons. Now coming to this final span CD, here by applying sigma Fy, there is only two forces here, that is RC and minus 10. So RC is equal to RC minus 10 is equal to 0. So RC will be equal to 10 kilonewtons. Now the next step is to find the final support reactions. We will get these final support reactions by adding these values. Here we had only one RA value, so RA value is minus 16.61 kilonewtons. Coming to RB, in this span it is 16.61, and coming to this span it will be 19.83. So the final RB value will be 16.61 plus 19.83, which is equal to 36.44 kilonewtons. Now coming to this RC value, in this span BC the RC value is 10.17, and coming to this span CD RC value is 10. So the final support reaction of RC C is 10.17 plus 10, which is equal to 20.17 kilonewtons. So finally we had calculated the moment values and support reactions for this beam. So the final step is to draw the shear force and bending moment diagrams. Now coming to the bending moment diagram, this is the bending moment diagram which we had drawn in our first step, free bending moment diagram. So by adding these values, by plotting these values here, we will get the final bending moment diagram. So MA value here is 17.16 kilonewton meters, which I am marking here, and here MB value is minus 29.29, mark 29.29 here, and I had joined it with a straight line. And coming to MC, it will be minus 10 kilonewton meters, so I mark 10 here and I joined it with a straight line, and MD here is 0. So since I had drawn this minus 10 here, I will omit this one. I will clear this one. So and here, and coming to this point, here MA is plus 17.16 and here it is minus 10. So I left this like this. So this is the bending moment diagram of this continuous beam. And coming to the shear force diagram, at this point the RA value is minus 16.61. So I marked it here, and from here to here there is no force acting on this beam. So the value remains the same. The shear force value remains same till here. And here at point B, there is a force of 36.44 support reaction acting upwards. So minus 16.61 plus 36.44 gives me the shear force at this point, which is 19.83 plus. Now from this point B to till this load 30 at this point, the shear force will be same, since there is no force again acting here. Now here a force of 30 is acting downwards. So my shear force will be plus 19.83 minus 30, which is minus 10.17. Now again from this point to this support C, there is no force acting, so the value remains same. And again here the RC value is 20.17 plus 20.17. So the shear force here will be minus 10.17 plus 20.17, which gives 10. Now here the shear force value is 10, and coming to till here the value will be 10, and here there is a force of 10 acting downwards. So the final shear force at this point is 10 minus 10, which is 0. This is how we will analyze a continuous beam of sinking supports. Thank you. Please subscribe for more videos.